Good morning everyone. This is the tutorial which will help you to understand the basic idea of different quadrants in trigonometry, and you will come to know angle in trigonometry may be greater than 90 degree, maybe greater than 180 degree, maybe greater than 360, maybe more than that. How to find? With the help of this unit circle I have drawn here, trigonometric ratio of any angle that I am going to discuss with you. In figure you can see that unit circle is given there. Its radius is 1 unit. All of you can see that. I have divided the whole xy plane in 4 quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. And here in this spreadsheet I have taken the angles 15 degree, 30 degree, 45 degree, this manner. Okay. Now what you have to do here, before you start the function of this unit circle, you have to remember the trigonometric ratios of those angles which you did in class 10 or class 9 level. That sine 30 degrees, half you know, cos 30 is root 3 by 2, it is 0.87 approximately. Similarly like that, cos 60 is equal to half, cos 90 equal to 0. Now question automatically arises, why we restrict the concept of angle from 0 to 90 degree? Why it cannot be more than that? That I am going to explain. That trigonometry it is possible, angles may be more than 90 degree. Now there will be an initial line in trigonometry always, that is our x-axis here, and the rotation is in terms of this slider, which will show you the ratios of 15 degree, all these things. How it shows, that I am going to show you. Here the concept of positive and negative angle, you must know. The slider, although I have kept in such a manner that I have taken its value in such a manner that it can give you the positive angles only. Automatically question will arise, what will happen if we take negative values? That can be explained in similar manner. The concept of positive angle is that the initial line should rotate in anti-clockwise sense, and here the slider I kept fixed in such a manner that it will rotate in anti-clockwise sense only. Okay, and I have set it from 0 to 720 degrees, so it can measure all the angles between 0 and 720 degrees. Okay, in first quadrant you try to remember the coordinate of a point. In first quadrant, this is our x-axis, this one x, this is y-axis. Coordinate of a point on this has y coordinate equal to 0, that's the coordinate of this point is 1, 0. This is 0, 1, the point lies on y-axis, this one minus 1, 0. This is 0, minus 1, it's like this. Now, when I start rotating the initial line in anti-clockwise sense, just before that, you look at this position. What is the measurement of the angle slider showing? That is 0 degree here. Okay, and you know the value of sine 0, cos 0, all those things you know. Although I did not show it here, but you all can say that what is the value of sine 0 here. Sine 0 is perpendicular by hypotenuse. Here hypotenuse coincides with the base, so sine 0 going to be equal to that hypotenuse, that perpendicular has no existence over there, but base and hypotenuse both are there, both are of length 1 unit only, so sine 0 is going to be equal to 0. What is cos 0? Cos 0 is that base by hypotenuse, they are of equal length, value will be equal to 1. Accordingly, you can find the trigonometric ratios of all the angles. Now what I told you, just if the slider rotates, if our initial line rotates in anti-clockwise sense, then a positive angle will be formed there. Due to its rotation, we will get a positive angle. Let us see how it's happening for 30 degree. Okay, this is your 30 degree. You all can see that the radius of the unit circle is equal to 1 unit. This part is 1 unit. This length is also 1 unit. But this perpendicular and the base, they are not of 1 unit. If you have drawn a perpendicular here, that length of perpendicular by geometry, you can easily prove that it is going to be half, 0.5. So this has coordinate 0.5, this one has value 0.87. On the x-axis, if we take the points very close, it is not shown here, but see, this is 0.5 here. 1 is there in between that, very close to 1.87 is approximately. And the value it's showing exactly, it is 0.87 over there. 0.87 is the value of root 3 by 2. And 0.5 is 1 by 2. So sine 30 degree, if you calculate, what is the value of sine of 30 degree? Just look at the table. Simultaneously, it will show you the calculation. It is 0.5 and cos 30 degree is root 3 by 2. It is 0.87. It is shown here clearly. This 30 degree trigonometric ratio, that cosine 30 equal to 0.87, sine 30 will be equal to half. Okay. Now let us go for the next one. That is for 60 degree. Let me go. Yeah. This 60 degree means this length will be 1 unit only because it is unit circle. This length measurement, I am taking the help of this circle, this unit circle. In GeoGebra, it always gives the point, that point that we have got 0.5, 0.87. This is 0.5 and this is 0.87. And this length is 1 unit. Okay. So, if this one 60 degree, what about cos 60 degree? This one 60 degree, cos 60 degree is what? This length is base by hypotenuse. It will give you 0.5 by 1 always. Okay. So cos 60 degree is 0.5 by 1. This will give us the value which is equal to, see, 0.5. This is 0.5 cos 60 because this is base and this is the hypotenuse. Hypotenuse is 1 unit. This is 0.5. By definition of cosine of an angle, this will be 0.5 by 1. This answer is 0.5 only. Okay. This one coordinate again being given over there 0.87. So sine 60 degree will be 0.87 and 0.87 what you have taken sine 60 in class 10, that was root 3 by 2. So if it is root 3 by 2, if you calculate approximately it is 1.86 by 2 that is coming. Root 3 is 1.732 by that thing, it's coming 0.87 approximately. Okay. So sine 60 degree, it has given the correct answer. Over there in unit circle, cos 60 degree equal to 0.5 and sin 60 equal to 0.87. Okay, this one. Now let us go for, see, I am going for this 90 degree case. So we rotate it anti-clockwise. Yeah, this is 90 degree. All of you know what is the value of cos 90 degree. You have done it before. Till this all are known to you. Just I am giving a proof with the help of geometry. How nicely it can come in a unit circle, that I am going to show you. Okay. So for 90 degree, you see, first one is cos 90. Cos 90 is base length is 0, hypotenuse is 1. So this is going to be 0. Sin 90, perpendicular is 1, base is also 1, it's coming 1 by 1, that is equal to 1. Till 90 degree you have done all before. I am going to do beyond it. The first thing you have to remember, the angle made by this rotating line with the original position, that is along positive x-axis, is the angle. That angle should be positive because it's rotating in anti-clockwise sense. So if we go more, let us calculate. Say I am going to calculate 120 degree. Yeah, this 120 degree, what is the value? That method, that finding sine 120, cos 120 is done in normal trigonometric class. It's not a problem for you. By using a technique, all this can be determined. Now this GeoGebra support for that problem is, it can tell you the exact value what you got there. Okay. If you go for calculating sine 120 degree, cos 120 first, say cos 120, this cosine, in this table cosine comes first, then sine, then tan. Tan I did not calculate, not required, you just do find it for 120 degree first. Okay, that cosine 120 degree. It is showing you the value minus 0.5. See the coordinate here. Yeah, the coordinate of the point is minus 0.5. This way minus 0.5, this way 0.87. So for 120 degree, it is minus 0.5, which is cosine of 120 degree, and sine is 0.87. This you must have learned that sine 120 degree, when you find it is sine of 90 plus 30, that is cos 30. Cos 30 is nothing but root 3 by 2, that is 0.87. So again here it's putting the value you get exactly. Now for cos 120 degree, it is cos 90 plus 30. If you go on calculating, it will be minus half. So you see, it's getting minus half. Okay, and the angle is showing 120 degree. Anti-clockwise rotation, this angle with positive direction always should be considered positive. Let us go for next. Next means a convenient angle. You take 135, say I have taken. You just mentally calculate what you learn in normal trigonometric class. Sine 135 degree is what? Sine 1 into 90 plus 45 degree, that is cos 45 degree. This is nothing but 1 by root 2. So sine 135 degree equal to 1 by root 2. What about cos 135? See, 1 by root 2 means 0.71. 0.71 it is shown here for 135 degree. And what about, I keep it here. So what about that cosine 135 degree, cos 90 plus 35, second quadrant cos is negative, so it is minus 1 by root 2, its value is going to be minus 0.71. That I have taken, cos 135 degree equal to minus 0.71, sine 135 degree equal to plus 0.71. They have exact value, their numerical value same, but signs are opposite. So this is an example of angle which is larger than 90 degree, and we found its value. Let us go for more than that. If it is 180 degrees, see how nicely it's showing the result. This point has coordinate what? Minus 1, 0. And cos 180 degree, all of you know, tell, because the table gives cosine value first. Cos 180 value is how much? Cos 180 degree value, it will be minus 1. Cos 180 degree equal to minus 1. Sine, this is 179 degree. This one 180 degree. So this will give us cos 180 equal to cos 90 plus 90 minus sine 90, value is minus 1. It is supported by this GeoGebra diagram, which gives you the value minus 1 only. And sine 180 degree, sine 90 plus 90, that is equal to cos 90. Cos 90 has value 0. So sine 180 has value 0 degree over there. Okay. Not only that, any angle, this I am doing for standard angle so that you can understand the idea properly, because you are habituated with the angle 0 to 90 degree. That's why angles are chosen that manner. Let us go for an angle. Actually, in this quadrant 90 to 180 degree, if you go on calculating a trigonometric ratio, normally you say that you have learned that all sine, tan, cos. Here it is very easy to remember. This is all means all positive quadrant 1. In this quadrant only sine is positive, rest negative. Sine and cosine both. So here if you see that length of perpendicular is 1 unit, you can see that. And the height is here 0.71. This is showing you. So what is the sign of sine over there or cosine over there? It will remain positive because perpendicular by hypotenuse, or hypotenuse by perpendicular, both are positive. So they are only positive. Rest of them will be negative. Cosine, when you are going to calculate, it is minus 0.71 by something. tan, cosec, all these when you tan and sec, others when you are going to calculate, they will show you the negative value over there. So in second quadrant, only sine and cosine or sine and cosec positive, rest of them are negative. What happened in quadrant 3? So let us take an angle in the second quadrant. Third quadrant. You see third quadrant. What is happening there? Coordinate of this point is what? Coordinate of the point is this thing. Minus 0.87, minus 0.5. So really it's negative x-axis, it will be negative, negative y-axis, that also will be negative. Okay. So if you are going to calculate anything except tan, tan will be what? Perpendicular by base, both are negative, negative by negative, it will be positive. Chord will be what? Base by perpendicular, that also will be positive. Except tan and chord, all are positive. That's why we say only tan positive here. Tan positive means automatically its co-function chord is also positive. Now similarly, let us take an angle in the fourth quadrant. Fourth quadrant, which one positive? All of you know the rule. You will say that I know it already. It is not required, but this is true for all students. They will be able to get the value of any angle in any quadrant. So in this quadrant, this is positive and this is negative. If you go for calculating cosine, that base by hypotenuse, and sec, these two are positive quantities, rest will be negative, because in the rest one positive, one negative term involved. Like sine of 300 degree, if you find this is 300 degree, you know, sine 300 degree, how do you find it? That perpendicular by base, that perpendicular is negative and this one base is positive, so it will be hypotenuse is positive, minus 0.87 by 1, answer is minus 0.87. This way you can play with any angle here just by rotating it in anti-clockwise sense, you will get it. Okay, see all the angles is coming here. So it will tell you one important fact here, that if we rotate the initial line, suppose we have rotated more than 360, see the position of the slider, it has come to the junction with the x-axis, here again it has come back, so angle 360, more than that, because on rotation, if it goes on rotating, then angle is going to be described over there. It is more than that, then also it is telling its value. In fact, in trigonometry, angles may be of any value. It may be more than 360 degree, it may be more than 720 degree, it may be larger than any angle you can imagine. Okay, that's all. You all play with this diagram. What you have to do there, you have to download the GeoGebra app. Its size is very small, 3 KB only. So it will not disturb anything, any data, any other app in your computer, and it is safe to download geogebra.org.classic file. Classic file format you find, you download it and start experimenting with this thing. Thank you. See you again.